Hello everybody, my name is Yuri Rabover. I'm one of the founders of VMTurbo, responsible for the product strategy. As Shmuel described before that, I was working in the CTO office of AMC, where I came with acquisition of Smarts, our previous company. And before that, I had a couple of other startup storage management, and before that, I spent a long career in researching operating system resource allocation in the Russian academia. Before I go to the demo, I want actually to spend maybe 10 minutes elaborating a little bit on the details of typical cases where our users of our software, and in general, people working, managing IT, face on a day-to-day basis. Basically taking the overall approach which Shmuel presented and just give a couple of specific examples just to illustrate typical issues, customer-facing, typical challenges when they need to resolve this, and then use this example to illustrate what could be done, and then jump to the demo from there. So let's start with describing a typical dependency chain of a typical application in the data center. Let's start with an application, let's say a SQL server, which part of some application suite running some transaction. So this SQL server as an application is running inside a virtual machine. Call it VM1. Inside this virtual machine, it's almost like a real machine. You have a network adapter, and you have an HBA adapter, you have virtual memory, you have virtual CPU, and that's basically what the SQL server is using as its resources. This virtual machine runs on some physical host, call it host 1. Which has physical CPU, physical memory, real, not virtual, real NIC, real HBA adapter, and that serves the resources of this virtual machine. This host is connected through the HBA to some data store in a virtualized environment. Here is a data store 1, which provides to this host and VMs running inside with adequate amount of space and IOPS to serve IO operations. And the NIC is connecting you to some switch, virtual or physical switch, which connects you to the rest of the network and serve you the IO capacity. Which, by the way, the storage connection may be actually layered over the network connection if you use iSCSI, and that's actually part of the network. The data store, in turn, could and usually resides on some volume in, let's say, NetApp infrastructure. It's actually part of a volume, vol1, which resides on some aggregate and disk array, which there are multiple shelves there. It's a disk array 1, which is connected and managed by some kind of a storage controller 1. And this is a typical dependency chain into a typical data. So this is what basically we see every day, and that's how. Now, no, I don't. Okay, I hope.
You cover an interesting thing there. We talk about this is typical, and it is typical. However, of course, we love the word vSAN that gets thrown around a lot, and vSAN from the VMware side is a reality, and it will be full GA release soon. vVols, there's a lot of abstraction layers that are happening on the software side, or on the storage side, and they're now going to change what storage really is underneath it. How are you going to find that control and that real management level when suddenly the storage is distributed and only presented to you as a top abstracted layer?
Yes, this is actually an excellent example. I'm just illustrating something simple, a snapshot of what's happening today.
Right.
But you're absolutely right. What's coming is additional layers of abstraction. By the way, 15 years ago, this VM and physical server didn't exist. You ran your SQL server right on a physical host. Virtualization introduced this layer. Now, why we here all? Because there are challenges of managing this layer. You're right. In vSAN, as we speak, we're introducing a new layer of abstraction and storage. Guess what is going to happen? Tomorrow, we'll have to deal with this additional layer of abstraction. We're trying to use the same approach there, by the way. And I will try to elaborate on your example, too. But now, if this is a typical dependency chain, let's now look at how people manage it today. And consider the following kind of example. What is the source of delays here? We already saw our abstract way in general, source of delay in any piece of infrastructure. But let's try to map these delays to every component of this and see how people observe it and how they deal with that. Imagine that you have a user here using this SQL Server application, which is sluggish. He's sending a request, and he has to wait a little bit. His requests are delayed. If you're an application owner, and you're responsible for SQL Server application, what could be the reason for this delay? Maybe non-optimal index structure. Your joins are very slow. Your query is non-optimal. You need to introduce an additional index. It could be a purely application-specific problem. And if you fix it, your application will start working faster. That's one possible thing. Going down here, your SQL Server is a process running inside a virtual machine, which may be a big process requesting a lot of memory, and your VM has only 2 gigs of RAM, and the SQL Server virtual size is 10 gig, and the working set is close to 2 gig, and effectively when it needs more pages, it cannot get this, and what happens? The guest swapping starts. And the guest swapping starts, all the response when you need a page, they're slowing down. As a result, it may cause the sluggish response too. Now, at the same time, this VM is running inside a physical host, serving the I/O requests from this SQL Server. First of all, the physical memory on this host may not be sufficient. You may be swapping here. Or, if there are multiple VMs running inside this physical server, and they also issue a lot of I/O requests, the HBA queue may be growing, and requests may be queued, and you have to wait longer to serve a specific I/O request. From one application, there are 100 other VMs running. So this is another source of delays here. You're waiting in the queue. Or you may be actually running on a particular data store. You may be running, again, 10, 15 I/O hungry VMs, and it's like I/O blending effect. They start sending these I/O heads back and forth and delaying each other. So as a result, you may still see a sluggish response on the SQL Server. Or you may be running inside a disk array attached to a storage controller, which is in the middle of disk scrubbing. Its CPU very busy. It's doing deduplication, compression. As a result, huge delays in the storage infrastructure, which again may manifest itself as a sluggish response. I just illustrated a typical thing which an application owner may see, and how many different things may cause that. Now, how it's done typically today. If it's indeed a SQL Server problem and you know what it is, you will go and optimize your index structure. If you need more memory in VM, and let's assume that you know that, which you may, but let's assume you know that, you will probably need to upsize this VM. If the HBA queue is too long, there are other hosts running here. You may figure out the host which has shorter HBA queue and move this VM there. Again, assuming that you know that that's the reason and you know what to do. By the way, when you move from host to host, you cannot look only at HBA queue. What about ready queues? What about memory? What about CPU, network? So you really need to figure out. But let's assume you know all that and you can move that. If you're running on a busy storage controller infrastructure, you may want actually to move to a different NetApp cluster, move the entire volume there, because moving VMs across data stores within overloaded storage controller makes no sense. Everything is busy. By the way, when you decide to move VMs across different data stores, you found a data store with low latency, and you move your VM there. What you didn't realize, that this data store has a snapshot partition which is almost full. You move the VM, and all of a sudden you're running out of space.
But are those recommendations or is it?
No, not yet.
Automation?
I'm just illustrating
Yeah.
typical decisions people
Of
need
course.
to make.
course.
But now, by the way, I just said, what if? By the way, all these things may be happening at the same time.
Exactly, but the next minute it may be completely different.
Yeah,
absolutely.
but the whole point of this is actually that you don't want to be there.
Yeah.
You don't want to be in this loop of troubleshooting and trying to figure out.
Of course,
Because once you are in this loop, it's not easy. If you are letting the environment to get into those type of states, you are not in a good state, and it's not easy for anyone to figure out, definitely not in software, but definitely it's not easy to anyone to figure out what is the problem and what to do with that.
And by the way, in that regard, who is looking at that? The application owner team is looking at that.
Yes.
The infrastructure owner, the data center owner is looking at that, and the storage group is looking at that. All these problems may be happening at the same time. Everybody has its own little exposure. As Shmuel said, it's too late, and you always you're chasing something here, something here, and you have to do it all the time. I'm just illustrating
Of course.
that this is
The whole idea of our system and our concept is to avoid getting into those situations. If you're there, we don't do any better job than anyone else out there. The key here is, how do I keep the environment in a state that those things don't happen, or minimize the risk that you'll get to those type of situations?
Well, I think Marco brought us a great point up in that we are seeing the decision engine is coming up from the bottom now. Obviously there's a lot of, for heavy, VMware vCloud users, we're going to be using storage IO control, network IO control, and a lot of those decision engines are down at the hypervisor layer. So where is that value going to come? I know obviously that's a specific case, and that's what it is. It's a very dynamic, and there's a lot of intelligence being baked in at the hypervisor, the control layer, that it starts to erode from some of the value we may get back from your product, at least in that particular environment.
So it's the application awareness in here that,
Right.
and that's what we're seeing VMware trying to do. They're pushing a whole heap of products that are application awareness, but only.
You see, go back to my initial statement. If I don't believe you can solve the problem that we are trying to solve by looking here and trying to optimize here.
No,
Because if you are trying to do that, you don't understand what the service that the application is getting. So you're looking from here. You may be doing the best thing for this element,
Right.
but that doesn't mean that it's the best thing for the application that happens, or all the applications that are sharing that element, whatever the element is.
Question.
I'll just give an example because this kind of resonates with me. If I have a filer, and it could be, I guess it could be an NFS store, data store, or a CSV, or just a bunch of LUNs attached to virtual machines. Inside that filer, there's only a budget of 7,000 IOPS, maybe. And if my regular workload is consuming 3,000, 4,000 of those IOPS steady, and then some big job like a SharePoint query or something hits another LUN in that filer and spikes it up to, takes the IOPS budget from 4,000 to 6,000, everything in that filer is going to be a little bit, a percentage slower.
correct.
Right.
So that's kind of how I'm thinking of it. I don't know if that helps you guys, or if that kind of.
Yeah, no, I think it's more, my thought is, it's kind of that the devil's advocate question of most of the virtualization admins where we're trying to latch in more to an ecosystem that's happening, in VMware or Hyper-V or whatever. They're building a tighter ecosystem, and agree, like I said, I'm not taking away from what you guys are doing, but I know these are the questions that will always get asked.
Right.
And that's that layer where we've got to try to push the traditional admin away from what they view the economics engine. They view it in the hypervisor down to the storage. Mm-hmm. So they may not see above and see the ability to really strip right down, from the storage bits all the way up to the top where the consumption of that resource is happening.
Right.
And that goes back to, look, I mean, I got to this space in '92 and I started in this space with the notion that the way to manage complex environment, or the starting point to manage complex environment, is a common abstraction across the entire environment. I never believed that you can build a software solution. You can build a lot of tools that helps people make decisions. But if you want in software to drive decision, your starting point has to be that you have a common abstraction across the entire IT stack. You cannot build a solution in software that will make decisions, right decisions, by looking at individual elements and independently making decision based on specific things at that level of the element. The whole key here is that our starting point is to say, look, it's not about the spindle, it's not about the aggregator, it's not about a specific VM, it's not about a specific memory on a specific host. It's about this IT as a box, and have a common abstraction that enable me to make the right decision as it relates to the service that I'm getting from the box, by looking at everything with a common language, where what pricing gives me is the ability to compare latency with transaction per second, with memory and VMem and vCPU, that if you think about it, unless I give you all the data and you drive the decision, you cannot have it any other way unless I have this common abstraction that enables me to make those type of decisions to drive the environment to a state. And again, by the way, it's not about, and that's important to understand, it's not about solving a problem on a given thing in your IT. It's about how do I deliver the service the most effective way? And it's two different things. And we as IT people trying a lot of spending our life, if you want, troubleshooting and trying to fix problems. But if you think about from a service delivery point of view, the goal of IT is not to fix and troubleshoot problems. The goal of IT is to deliver the service.
You do troubleshoot when something broken, but that's an emergency, not a day-to-day operation. What we see, it's a day-to-day mode of operation in delivery of service, and that's what we find very counterproductive.
But is there something that is measuring what's normal? You can have like a CPU that's running 99%, that's normal, right?
But
Is it like that, or?
Well, so 99% CPU will be normal if the applications that are using it are getting the service that they need, and the price of getting additional capacity is prohibited.
Right.
But if I can
right?
What?
Every week or.
But I'm saying so the normal, there is no normal. You see, there is no normal, because the normal is very much depends on what is my supply, what is my demand, and what is the cost of my supply, and what is the benefits that I get from executing my demand. And that's something that's what the market is doing. It's figuring out that state. So if it happens to be that, yes, I'm running at 99% CPU,
Yes.
but it will cost me $1 million to buy another CPU, okay, so I'll suffer. I'll take the heat and
Right, but it may be like a single-threaded application that you cannot add a second CPU, and it's like it's a thing that runs every day
Right.
yes,
or
and
an hour, and it's normal, right?
so, but again, if that application is important to get better performance, and the price of buying a bigger CPU or providing bigger machine is acceptable, the normal would be then the decision would be, okay, let me find a configuration in which the CPU utilization won't be 99%. But if it's an application that can perform the way it's performed, and the price of getting additional capacity is very high, okay, I'll compromise on that state.
Okay, but my question is more like, does VMTurbo know that it's normal behavior?
VMTurbo doesn't care.
Right.
Okay.
I think we follow the supply and
it
demand.
is generating recommendations.
Right,
So it does care.
but there is no notion of normal. You see, there is no notion of normal. What is normal?
Well, let's
Normal
give you an
is-
example.
is like
in-
self-learning,
optimal,
right?
maybe optimal is the better word.
Okay, so again, so what is optimal? The optimal in this case is depends.
Optimal is, the inputs.
So I'm
or
saying,
the
so
outputs that you need.
so as he said, the CPU is at 99%. Is it bad or good? And I'm saying it depends. It depends what is the level of transactions per second that the application are doing at that point of time, and is that transaction per second is acceptable giving the priority of this application, and depends how much, if I want to get it to better, to a more normal CPU utilization, what it will cost me to provision that CPU.
All right. Think about the following example, just to elaborate what's normal, what not. If you have only one host, which is 99% utilized, and you cannot buy anything, this is your only choice. If you have less loaded host, and let's say it's not peaking, and because at 99% it could be okay if you're not peaking, but if you're peaking, it's bad. If within your environment you have a better place to run this VM, we'll make this decision for you. And that, but if not, and you cannot buy a new server, we will, by the way, we will recommend you to buy a new server.
Exactly.
Can I give an example?
Not
Like-
every
Not every time. No, no, no.
Depends on the budget of the consumer,
Right.
and depends on the cost of of what needs to be provided.
It's more like you have monitoring solution that's recommending what to do better, right? And you can execute it with automation. That's
So we
how I
have,
see
so
the product.
I think well, yes, yes.
Right.
So-
We will always recommend, and you could optionally execute this action.
Yes, of course.
That's basically
course.
automation is not our goal, but is a very likely and suggested feature what we recommend people. You don't have to automate. You
Can you
could
turn off
follow
those
it.
recommendations permanently?
Yes.
I just want to run that at 99% utilization.
Yeah.
Fine.
Yeah. You can. Yeah.
Of course.
And you can. And again, you can again. If you think about the control knobs that you want to have, is okay. I can give that application in the top of the supply chain more power, more criticality by giving it more budget, and that meaning if it needs to spend more money and as a result drive provisioning of more capacity, it will drive more provisioning of capacity. Or in the same time you say, no, you know what, I'll reduce the cost of my capacity because I can get it cheap. So all of those are the knobs. Again, if you think about an IT, again, not at the point of turning up the CPU, the knobs of utilization of entities, but rather look at the all IT as one black box that has cost on the bottom, budgets on the top. How do I drive it to satisfy those constraints?
Of course.
I was just going to say this kind of speaks to where I work and my career, because what happens in my situation is the business comes to me and says, we need you to deliver this application at these speeds and here's your budget.
Right.
So, you know, come hell or high water, that's my job. And if I let anything get in the way of that top tier application and that service level agreement that they've put on me, that's not good. So I think I'm understanding it from that standpoint. It's not an issue of normal or optimal. I think it's more like, what have I promised to deliver to my business?
Can you deliver it?
And what are the trade-offs that you have to make?
Right.
Because
And
it's
and they need to be cognizant of that, and that this gives me insight into that, you know, if my top tier application is going to be as fast as I say it's going to be, as you want it to be, but you know, that B workload, it's going to be a little slower.
Or
we
basically,
buy new stuff.
you could actually ask the following question: what it will take to provide this SLA? If I want to have 100 transactions per second, we run our software and say you need to provision 2 additional physical hosts at the cost of $20,000. That's one of the answers to your question. If you want in your current environment this level of service, you need to spend that amount of money. It's up to you to decide to degrade the service or spend more money, but you always need to find the right answer. This is where we try to help you.
I think just to build on what Marco said, like to give an example, back in the old days, SAP, one of the kind of measurements that would use was user perception around response time, and if it took more than 1 second to get a response time from SAP GUI, then that was very, very bad. And that was one way of measuring the application's performance. And so we can measure latency for SQL Server, be it logs or data or whatever we're looking at. But, you know, so there's an example of, I suppose, I think that's kind of the point Mark was making, that, you know, what's normal for SAP or for some other application as opposed to what's normal from a hardware point of view, or like, you know, a bunch of components like vCPUs or memory or that kind of thing.
There are a couple of ways to look at this question. First of all, yes, from the end user point of view, you're right. 1 second is probably too much and he is not satisfied. And from the application owner point of view, you're right, that's a measure. However, if you're an infrastructure owner and you want to deliver the right service, going back to the question, what is 99% is good or bad? What's wrong with 99%? If your load is peaking, then every percentage of peak may cause you huge delays there. However, so basically your goal as an infrastructure owner to configure, provide your infrastructure and reach the equilibrium on the workload in such a way to minimize the risk of load fluctuations. In that regard, answering your question, 99% CPU is probably too risky to run the load. And we will tell you if you have a better way of reduce this risk of an infrastructure owner, do that. By the way, we're somewhere here, we are not the application owner, but by doing what we're doing here, we will help the application owners to provide better service as well.
I'll tell you the way, I know a company who solved that problem by, you know, putting a sniffer on the network and breaking down the actual response time for a network database. That was the solution, and it was kind of a one-off product that a company here made. So, but it was highly valuable to any company who had that, because they spent a lot of time troubleshooting that problem, you know, trying to figure out was it you know, network, was it back end, where was the problem? Right. And that's an unusual solution, but it's just one that happens.
Right, but again, we are not in the business of trying to identify where in the network was the bottleneck that caused whatever. That's not. I think it's important. But I want to pick up on what you said. So if I want 1 second response time at the SAP level, okay, and the CPU is 99%, okay. Now, when I say the normal is depends, okay, I don't get the 1%, the 1 second response time, okay. Do I want to force it? I.e., is the application critical enough? It has enough budget that I want to force it? That's question number one. Mm-hmm. And if the answer is yes, okay, what is my trade-offs? Do I spend more money on more capacity, or there is some other application that I can suspend while I'm giving that application the more power to basically reduce the CPU and make them meet the 1 second response time? All of those type of decisions are trade-offs. So there is no one normal. It's the normal is an answer of the trade-off. That's exactly what we do in real life. The equilibrium of the market is a trade-offs between, okay, what is my demand? What is my supply? What is the cost of my supply? What is the budget that I have to satisfy my demand? And somehow, magically, we end up in some situation that's how we configure ourselves in life. And the same thing, this is the concept here. Right. That the IT will get you to that configuration.
But I must say, in real life, with monitoring applications, you receive a lot of false positives, or if things are not configured correctly, right? So it would help if the application knows what happens every week, right? And it can, of course, recommend that to give another CPU or move the VM or
Right.
Right. That's what you will see from us. That's exactly what you will see from us.
That's what we are doing.
Right.
Exactly.
And what we do, and the reason I illustrated this, all these decisions of reaching this equilibrium happens at every part of a supply chain. They could be independent decisions, but together, if you look at this as a whole, we'll end up delivering the application service levels. Even if we don't measure the response time here, let's assume we don't know, we don't measure. By the virtue of bringing to the equilibrium all part of the supply chain, the performance risk to the application will be minimized. Because let's assume you measure the application response time and see it's 1 second. It's bad. What do you do next? It's not yet a prescription. You know one thing, your service is degraded. We don't try to answer this question. We try to bring you the service within the expected time. That's it.
All of us IT people is, you know, the user rings up and, you know, what's bad and, you know, what does that mean? Or, you know, it's their perception, so to speak.
Right.
Even though we might think everything looks pretty good.
Right.
And, you know, it's a big problem. So it's a bit of a holy grail for me that, you know, mapping the application down, I don't know if it's...
Yes.
Right.
You've obviously done a lot of it, and this is the
Right.
correct model. I think the cost model is the way to do it.
But it's, I agree, and it's important to understand what problem we're trying to solve. Like, we are not doing root cause analysis. We are not troubleshooting. Where you could use our system to get the data for troubleshooting, a lot of data, but it's not our goal. Our goal is to reduce the risk of running the service and reduce the risk of running out of budget.
We're trying to prevent as many calls from happening as we can.
Risk reduction across the board is basically what we give you.
Prevention, I guess from our perspective, prevention is better than the cure.
Yeah.
Yeah, one of the things that obviously, and we've got a few folks that have tweeted out, again, you know, from a product side, and I don't mean to target you versus a product suite, but you know, in the VMware space especially, there's, you know, vCenter Operations Manager, and that's one of their real sort of flagship offerings in how it has a full top-down total intelligence engine, and it can be active. It can do active management as well. So if you're in a VMware-centric shop and they've really latched onto a VC Ops, data center management model, how do you put your extra layer on, you know, and where's the value proposition for folks that have already bought in, and so they're already per socket paying for that? Where does that extra, that socket price come into the value for them?
Yeah, we can spend all day just about VCAPs. So I can start with the first slide that I gave. VCAPs fundamentally feeds into that loop of giving you reports, alerts, abnormal, proactively, that things are bad or out of normal or are going to be out of normal, and it's up for the user to figure out what to do. Again, VCAPs cannot automatically figure out what to do because VCAPs doesn't have the semantic integrated view of the entire IT supply chain from the application to the data center. They have points products that collect data about all of that and give you a nice user interface to look at all of this data, but they don't have an underlying semantic data model that brings those all data points and all those relationships to be able in software to infer what to do at any given point of time. Furthermore, by design, if they have any recommendation, it's a reaction to some abnormality. And again, if you go to my presentation, this is not a solvable problem in software to figure out what to do, because again, if you respond to one or two metrics and you say, based on that, I want to do X, you're probably not doing the right action. So it's very easy. Look, I mean, I can write a script of 10 lines that easily will tell you, resize the VM up from 2 CPU to 4 CPU by saying, oh, if the vCPU cross some threshold, increase it, and if I look at the history, whatever, you have to increase. That's an easy script to write. I don't need VCAPs to do that. But as I said, as I illustrated at the beginning, that doesn't necessarily get you to the state that you want the environment to be in. So I think that, again, if you buy into what I explain as this IT operating in this perpetual loop of break fix or getting out of normal and then trying to get back into normal, and you believe that that's not the right way to move forward, and the right way is to figure out what is the good state and in software keep the environment in good state, VCAPs fit into that perpetual loop that I described, with a lot of nice user interface and icons and graphs and trends for a user to consume. And we are figuring out what is this state and keep you there. So if you think about an environment, a lot of our customers are VCAPs customers. We're coming to a lot of customers that actually VCAPs is throwing in for free, and which is kind of an illusion that it's free, but as I said, I can spend the whole day just on VCAPs.
It's almost a religious debate at this point again, because it's a very product specific and an ecosystem specific thing.
Right.
And I say, apologize, I don't want to go down the road of pitting you up against that.
So a lot of our customers are VCAPs customers, and if you think about what we do, the main value that they are getting by us is actually reducing a lot of the information that they are getting in VCAPs and a lot of the noise that they are getting in VCAPs, and actually to some degree make VCAPs more effective.
Right.
So
we actually don't need to compete. We actually could work together. It's just the reality of the market today, budgets and whatnot.
On the response side, so one thing, for a lot of shops, like you really target a lot of low latency application response, because ultimately that's the user experience. So if you're a true sort of DevOps oriented shop that has very adaptive apps that are stateful, aware, they're generally going to be deeply tied in with another orchestration deployment engine that's going to be actively managing. So those application layers, now most of that stuff happens cloud side, that's AWS kids, but there's a lot of internal stuff that's happening there as well. So how would you tie into that? Where can you tie in with other orchestration engines under the covers, so rather than bare metal deploying or VM deploying, or can you actually say, hey, here's a problem with this app, now can I trigger kick up a recipe in say Chef or Puppet
Yes.
or something other else that say trigger this action, and we can train it to engage with our orchestration engine that we already have in place.
yes.
Yeah, we have all that. We're capable of doing that. And out of the box, you don't need to do that, but you're right. In certain cases, specific DevOps shops with heavy investment into this orchestration infrastructure, think of our system as giving you the right recommendation and ability to intercept our recommendation, do something before, during, and after in our pre and post action scripts. And this is, by the way we work with some customers which require that. The typical case for us is change control. For example, you cannot size up a VM, a VDI desktop, if there is an active user, because if you do that, you'll have to restart it, and there is an active user. There is a change control. One of our large customers, an insurance company, they actually ask us to integrate with their System Center Orchestrator to do that. And we did. We give them the recommendation, and they take it and decide when it's safe to execute it.
Just so I understand the resource model that you guys are working on. If I, for instance, had my data center that was at full load, and I've got slow speed SATA disks and I've got high speed solid state disks, and all of a sudden at the end of the workday I have no load essentially on my disks, would I suddenly see tons of recommendations to move my data from slow speed disks to high speed disks because that's cheap for IOPS now?
You may see recommendations, not like tons, it depends on your load. By the way, we try to be very cognizant to your environment. We try not to overload with actions. For example,
I suppose there's a period of time where you actually
there is some hysteresis here,
the ops, and you're looking at 4 weeks before you actually
Yeah, I mean,
it's a sliding scale of
market,
history.
the market is much more complex than what I described.
right.
So the market takes under consideration in pricing, it takes consideration of history of behaviors of the resources. It's not just, now it is and here's the price. It's also taking under consideration the cost of the action. So if I move and the cost of the move is prohibited, and it can be fluctuating over time. So I can allow one move, but the price of the 10th move is much more expensive than the price of the first move.
And you will pace yourself down.
And I can make the price of the move so expensive that it will never happen. So there's all kind of things that plays in the market to drive a decision. So it's not just, just every fluctuation, every burst cause something to happen, but rather there is a whole pricing. The pricing is a very powerful function. I simplified it to make it, to illustrate the concept.
And constraints and policies which play into that. So if they've been defined in vCenter or some other cloud management platform, like I want these applications to never run on the high-speed disks, we try and bring those in and make sure that our market adheres to those policies. So we wouldn't make recommendations,
And by the way, those policies, which is also power, this is not, the policies themselves becomes commodities in the market that are being traded and being priced. And such, so there is no, so it becomes yet another things that the market takes under consideration as part of the pricing mechanism and the decision making.
And these are the valid questions, and we have hundreds of customers who actually run almost a full automated mode in these situations, and the practice shows that most of the time these concerns, there are no concerns here. Yes, sometimes there are adjustments, need to integrate with change control system, and we do that. But on average, if you follow the workload fluctuation in demand, and you have adequate capacity, and just it's a matter of bringing it to the equilibrium, we do the right thing. Interesting thing happens when you run out of capacity. If you cannot automate, by default you will see, like you said, recommendation, provision a new host. You asked the question, I always see that. Yes, if you're running out of resources, we will keep telling you, you're running out of resources.
It's like you run a report every week. It takes 2 hours, right?
Right.
Can I say, okay, this is normal?
Okay. Think about this the following way. If every week you run a report, and the report finishes in 2 hours,
yeah,
and we'll give you enough resources, everything is fine.
Yeah.
So think about the following. If the rest of the week this environment is not used at all, and you just once a week need to run the application, run the report, you could see a recommendation from us. By the way, during the week you can shut down this server because you don't need it. When it's time to start consuming resources, we'll recommend to bring it up.
Okay, but maybe I want to have an alert if it takes me 3 hours instead of 2. Or, if the report takes CPU for like 2 hours, a lot. And that generates a recommendation to make it 2 CPU, for example. Can I say, okay, don't give me this recommendation anymore because it's normal behavior and I cannot fix it?
Okay, we could, but think about the following. Let's assume that applications develop with a normal resource consumption. Let's say, in order to finish your report in 2 hours, and let's assume that's acceptable for you.
Yep.
In order to finish this, the average CPU and memory load is 50-60%. It means even if you give it more resources, it will still need 2 hours because it's the nature of the application. And this normal assumption will give you resources to finish it within expected time. Now, if for whatever reason you're running this report generator on a very congested environment and your CPU load because of other applications running there 80-90%, and that may impact this application, you will likely see recommendations from us to provision either additional capacity or take this huge CPU report consumer and move it to the host, which will give more resources. That will be our recommendation. But if the resources are adequate...
To answer your question about, again, I go back. Every action is priced. So if you don't want this recommendation to show again, price it in a very expensive. So whenever the engine will calculate, do I want to, I'm about to execute that to issue that recommendation, but this price is so prohibited that the alternative is I'm better off staying, giving prices, I'm better off staying where I am instead of executing that recommendation, because the benefit of the new state, the benefit of the new state plus the price of the action is more expensive to me than staying in the current state.
I think there's sort of two different philosophies at how you manage that are at conflict here.
Exactly.
So VC Ops will tell you, this is normal, this is abnormal, but it will not tell you whether either of those things are good.
Mm-hmm.
This kind of product is more saying, this is a good thing to do, this is a bad thing to do, but doesn't tell you whether either of those things are normal or abnormal.
Exactly.
And in fact, what you want is a matrix of the two that says, well, this is abnormal, but it's benevolent, so I don't care. Right? And VC Ops won't do that.
Yeah, exactly.
This is
but that's
normal
exactly what
but
I mean.
bad, and you should resolve it. This is abnormal and bad, and you should resolve
You see,
it.
we are not trying. I think you nailed it. We are not trying to alert you what's normal or not normal. We are not in the business to tell you what is normal. We are trying to. I'll go back to the beginning because it starts and ends with the first statement. We are solving one problem, which is what is the state in which application performance are assured while the environment is utilizing as efficient as possible. And by knowing that state and knowing what the actions I need to do to keep you in that state, we are continuously driving your environment to that state. Now, whether it's normal or not, it depends on what is your budget, what is your cost.
Of course, but you also recommend to move it to other storage or move it to other less busy hosts, because so it's a mix. By doing those actions, you'll get to a state that is a better state than the state that you are currently in, giving you budget and your cost. Exactly. Okay.
Should probably get into the demo. I do want to address one thing real quick, is that upon deploying VMTurbo, actually, I mean, typically within an hour or so, you'll get a series of recommendations. Again, because of the way the marketplace is working, it will come up with a set of decisions very quickly, so you don't have to wait 4 weeks. Again, we are gathering some historical information to track peaks and stuff.
That would be based on certain metrics, right?
Yeah.
I mean, you're talking about storage metrics that you can't derive within that time frame.
Right.
Okay.
Right.
But can I tell VMTurbo what my, I mean, you're going to discover what my budget is, right? What my resources are capable of delivering, but how do I tell VMTurbo what my most important application is?
You can go and say group whatever.
Right. Well, let me illustrate. For example, you go to the policy, you go to the application priority, say application. I have a couple of groups here, and you may say, for example, low priority desktops. You may say application priority is normal, or you may actually say select mission critical or low. These are examples of 3 fixed priorities. What's behind these priorities is our budgets. When we say application is mission critical, comparing with normal, it will have a bigger budget. Now see what happens when you run this mission critical application in the less loaded environment. The budgets are less important. If you have adequate resources, it's okay, you still have money to pay for them. Imagine a situation that you're running your mission critical application in the environment which is getting highly utilized on multiple resources. Memory, CPU going to 80-90%. It's becoming risky for this application. So if you have a mix on this host of low priority application and mission critical, a low priority application has smaller budget. The resource utilization are higher, the price is higher, and the low priority application will run out of budget sooner. Then what will happen next? If they cannot pay for the resources, there are 2 choices. Either move them to some cheaper, less utilized resource if it's available, and if not, shut them down. Free up the capacity for the mission critical application. One practical example, think about the following. A VM which runs a mission critical SQL server and antivirus software. If you look and imagine that you see from the outside this VM, vCPU is 99% CPU. You do one thing from the outside. I'm running my mission critical SQL Server. If I see 99% CPU, I'd rather give it more CPU power because I'm afraid that it will run out of resources. However, it could be antivirus which went rogue, consuming a lot of CPU, maybe bad signature or something. What we'll do in this case? You would rather shut down this antivirus. That's exactly what will happen in our environment. Antivirus will be low priority, SQL Server high priority. When the CPU load is high, we'll recommend shut down the low priority application. That's kind of a natural, this is what you would do anyway, and we'll do exactly the same thing. Well, and this is the way to configure.
You'd first recommend moving that low budget virtual machine to somewhere where CPU
if there is a way. If there is a way.
If available.
If not, well, tough choice.
And by the way, if the provision of additional capacity bursting to AWS is an option and it's a cheaper option, that's what will happen. So,
vSphere resource management, because one of the ways to achieve this, you haven't got the budget for this resource. So at vSphere layer, I'm going to drop your shares so you get less of it. You can afford 20% of what you're asking for, not all of it. Do you tie in at that level?
Actually, we did look at shares. And we initially thought that we can accommodate this. Actually, it's a law of diminishing return. The gain you will get from that won't be that visible.
For your controls, limits would be the right tool to say, you can afford up to this much, and that's what you get.
Right.
Yeah. Give me a report that a CFO would understand, so that when he complains that everything's slow, I can say, well, here's exactly where your spend is going.
Yes, we can give you multiple reports.
You can buy me a new server.
As a matter of fact, if you look at the dashboard, let me look at something here.
How much time does this take to properly configure in normal environments?
Yeah, I think that raises the great, we always talk about delivery, like you can deploy it in an hour, again, not to discount from that, that's great. But to really derive proper analytics and really get the value back, that hour goes away. The same as when someone says, oh, we're better storage because I can ship it to you in 10 days versus
weeks,
12.
Right?
I don't care. I have months.
I think that 90% of our customers are now download, up and running, and they don't, those type of questions that you're asking, those are second, third, fourth, fifth level of question. The typical user just run it as is.
Right.
Run it as is and get what he gets,
And literally, okay, we have 5 minutes left. And maybe less than 5 minutes, I'll give you a taste what you started asking. Indeed. What our users typically start from? They download an OVA file, 400 megs. So download and install the virtual machine, attach it to pieces of infrastructure you need to manage. We support vSphere, Xen, everything you can think of. You just authenticate yourself and hit discover. Within 10-15 minutes, we'll finish the discovery and get the first round of recommendation. Within 10 minutes, he will see the to-do list, top 10 actions you may want to perform in your environment to start bringing you to the better state.
Of course. But I must say, I have deployed it in my lab also.
Okay. So
and with any other tool, it's really rather difficult to really understand the tool in 1 hour.
Understand the tool? Yeah.
Yeah, to really, that's why I'm asking to really configure it.
So the usual process that we go to is download, and our SE and sales gets on the phone with the customer and have a WebEx session with him and demoing and explain to him what he sees and what he can get and whatever, and then goes through a process of demonstrating the value to the usual sales process. So it's not download and it's self-explanatory and you understand everything we do.
Of course. So that's why I'm asking, how much time would it need to do an advanced configuration and fine-tune and...
Okay, but these are two different questions. Let me address that. There is no need to fine-tune and configure. This time is literally zero. There is some time you're probably referring to understand what we're suggesting you to do. That depends, obviously. One reason why people indeed spend some time on that, they expect a typical monitoring solution. Show me what's wrong, alert me. They're looking for these alerts and then find them, and then they, oh, wait a minute, it's not about alerting. Correct. It's about, here is your cluster, we'll tell you to do this. Okay, and then it takes them some time to understand that. Once they understand, curious minds look at this, and if they're running safely, they say, okay, so we suggest to move to improve something. Can I do this? Say, yeah, sure,
but
go ahead. You hit apply, and we're actually moving it, and people...
But that are out-of-the-box things that are in the system. There's no need to configure other alerts or custom things or... the costs, right? You have
nothing. Out of the box, it gives you. We suggest to look at this best practices out of the box. By default, it will give you 99% what a typical admin would expect. That's kind of our.
I mean, typically.
I assume I must fill in how much things would cost me, right?
You have to tell
applications.
Well, if you want to distinguish, but there's some, again, we ship it with some defaults.
Okay.
And you can go in and configure.
Change
but again, I'm going back. Our typical customers are not going there. They are actually taking what we do and run with it. And actually they may come back 2 months, 3 months, 5 months after actually using the product and says, okay, now that I really got what now let me see if I'm trying to be more sophisticated. Let me refine something here. Let me refine something here.
I mean, typically we start with one of our Cs might start with a customer on a particular cluster, for example, and we'll see they get comfortable with the recommendations, they manually do that, but it's not uncommon for us to get a call, a week later, can I automate these recommendations? Yeah. We say, hit this button.
And what they just did. And
this thing goes to green, right?
Yeah. You select, you hit apply, and yes, we're executing it, and they getting more and more comfortable. And we show them, by the way, if you do that, you will arrive to this better state where a peak, mean and average load will converge. They say, interesting. They feel it's safe, and they start experimenting. And we have customers who actually very aggressively, within several days, automated their production environment.
I think the theme that we're seeing in a lot of this is that, and we can say this on our side because we are deeply involved in architecting and managing these environments and building and selling solutions and management solutions. Mm-hmm. Just like DevOps, what VMTurbo is trying to do is like a religious debate on how you manage your resources because of the value you're going to get back out of it. And that's why, so these are animated discussions for a reason, because we have a vested interest in how we tie things in. And we like control in a lot of ways, and we like like I said, there's good value that comes, but it's in practice, as you said, is where you're going to see it.
I think control is a key word here. Yeah. And I think that actually, if we as IT people wants to retain control over our IT, you need software like that will help you both, if you want, relinquish some of your control to software, but in the same time have all the control on, okay, how much and where are the knobs that you see, instead of having controls at the level of configuring, the level of utilization of a CPU, let's have knobs to control the IT as a whole, and then kind of give the freedom, if you want. Think about, I always like, now I'll use an analogy, is think about this as the federal government and us as players in the market. So is the federal government interfere at every transactions that takes place between me and you? No.
Well, what? I'm not sure if you've seen how our governments are. They do.
Well, okay. I won't get into political discussion. No, I'm not getting into politics. But think about the federal government is defining some knobs of control, and then it lets the players of the market make their own individual decisions within the control knobs and regulation or whatever the federal government decide, right? The same concept is here, is let us as the IT administrators and IT operation define the control knobs for the IT as a whole, as a market, and let the individual entities with when the storage has to interact with the server, a specific storage element needs to interact with a specific server element, stay out of it. Let it happen. And that's the philosophy, or if you want, the religious debate. Do we want to be in control by configuring the individual interaction between a storage element and a host element, or stay back and provide the policies of how things should happen and let them decide for themselves?
That's really exactly that, and I think that's the best phrase that comes out of it all is let the policy do it. We're doing it in network virtualization, we're doing it in storage virtualization. Policy-based delivery is the right way, and that's not just to go architecture, but like the paradigm shift in IT is around the fact that we used to love knobs, then we loved black boxes, and now we want black boxes that have knobs behind the panel that we can tweak if we want to, but we don't have to. And,
Right.
and
Right.
I guess
That's a right
I'm
way
sure
of
you guys have heard probably software-defined data center maybe 100 times this week.
Yeah,
So just think about how many more knobs there are, right? In software-defined storage, software-defined network, software-defined compute. So there's going to be 10, 100x more knobs than there even are today, right? So how are we going to settle those knobs? And that's really what
Software-defined
VMTurbo is.
control.
Yeah. It definitely.
Software-driven control.
That's what.
it.
This is the tagline.
Software-driven control.
This is the tagline of today's presentation: software-driven control.
I was just going to say, you whiteboarded it out that there's an application guy and an infrastructure guy and a storage guy is in. If you're in a smaller environment, that guy is one person.
Yes.
And that in my environment, that's me. But I look at this as a great way. I mean, you're doing what I do. That your software is doing what I do every day, and it would be a huge help to me in a lot of scenarios. But I look at it as IT people. The business has given us a budget, and they've bought us some equipment. We need to make it perform to its maximum potential and capability. We need to deliver what the business wants us to deliver, and a tool like this helps us maximize their investment, because that's kind of what our job is, or in my scenario, that's what my job is, to maximize.
I couldn't have summarized it better.
That's exactly what we do. And you a single person, and you use the value. We have a larger customer with these multiple teams, and he told us the value of our tool, it allows him to unify these teams to work as a whole, to deliver the service. And that's, in your case, you're a single hero, and it will make you probably more powerful. Thank you.
Yeah, I just want the report so I can get the new.
You have everything that we collect, and everything you see, there are reports.
Yeah.